Welcome to ETE MCQs. Now let us solve a problem from discrete time signal processing. The question is given as, let x of e power j omega denote the Fourier transform of the signal x of n shown in this particular figure. So you are given a discrete time sequence, x of n is given, and its Fourier transform, we know that it is usually represented by x of e power j omega. That is, in other words, if you take DTFT of x of n, it is represented as x of e power j omega. So this is our discrete time Fourier transform of a discrete time signal x of n is represented as x of e power j omega, and that is what is given for us here. So it is DTFT of a discrete time sequence x of n. Okay, and we have got three questions. We are supposed to answer three questions. It is given that the first one is, what is x of e power j omega at omega is equal to 0? Okay, this is what we are supposed to find. Now what you can do is, let me just write the DTFT formula, the discrete time. I will just write it here. The discrete time Fourier transform formula is given as x of e power j omega is equal to summation n is equal to minus infinity to infinity x of n into e power minus j omega n. So this is your discrete time Fourier transform formula. Let me take it as equation number 1. Okay, so this is your DTFT formula, and we already know that DTFT of x of n is x of e power j omega. Now the question that is asked for us is, we are supposed to find what is x of e power j omega at omega is equal to 0. We have the formula of x of e power j omega. You just notice what happens when omega is equal to 0. Okay, so from 1 I can say that from 1 you want to find x of e power j omega at omega is equal to 0 in the right hand side. Okay, you don't have omega here, you just have omega only in the exponential part. So you will have summation n is equal to minus infinity to infinity x of n into e power minus j 0 into n, 0 into e power minus j 0 into n, summation n is equal to minus infinity to infinity. You will have only x of n. So sum of all the discrete samples, that is what I mean by summation n is equal to minus infinity to infinity. X of n is nothing but sum of all the samples you have got. You need to add all the samples between minus infinity to infinity. But actually this signal extends only from minus 3 to 7. It starts from minus 3 and it ends at discrete value n is equal to 7. So you are supposed to add all the samples. So what do you get? You will end up with minus 1 plus 1 plus 2 plus 1. So totally you have 3. 3 plus 1, 4. 5, 6, 7, minus 1, it is equal to 6. So you add all the discrete samples, you will get x of n is equal to 6. 6. So 6 is your final solution for the first one. Okay, the signal extends between minus 3 and discrete values between minus 3 and 7. Okay, next we are supposed to find the second subdivision that we have is angle x of e power j omega. We are supposed to find only the angle. So what do you mean by angle? Angle is actually represented by, you just have the exponential part, you will have it as e power j theta. Okay, whatever you have in the place of theta will be the angle. Okay, in your e power j theta, whatever you have in the place of theta will be the angle. And again from 1 we are supposed to find the discrete time Fourier transform. But again, the point is, if you just notice this particular signal, it is actually, the signal seems to be symmetric, provided the signal is, if the signal, the discrete time sequence is advanced by two samples, you can notice that the signal is symmetric on either side of 0. On either side of 0, the signal is symmetric. So you need to advance the signal by two samples. Now what you can do is, let us introduce another signal. Let y of n is equal to, the another signal is, the other signal that we introduce here is represented by x of y of n, which is assumed to be equal to x of n plus 2. In other words, when the signal is advanced by two samples, you can notice that the signal becomes completely symmetric. What I mean to say is, what do you have for y of n? After I do this, what is your y of n? Y of n is nothing but two samples advanced in x of n. So what do you, x of n? Signal advancement of x of n. So the discrete samples will be, for minus 5, I will have minus 1. Then you have 0. And then you have 1, 2, 1, again 0, 1, 2, 1, and minus 1. So these are the discrete set of values you will have for y of n, provided x of n is advanced by two samples, and you have the origin, at the 0. Okay, you have the origin at the 0. Now the graphical representation of the signal will look like this. So when I advance the signal by two samples, this will be my final y of n. You can notice that the signal is symmetric on both the sides. On both the sides it is symmetric. That is what you see here. At negative index you have 1, minus 1 you have 1, for 1 you have 1, for minus 2 you have 2, for 2 you have index n is equal to 2, you have 2, so on. You can notice that it is symmetric on either side. In other words, the positive values of the signal y of n is a mirror image of the negative values of n. Okay, so it is a symmetric. If it is symmetric, the beauty is you will be having only the magnitude component. Okay, for a symmetric signal you will have only the magnitude component. It doesn't have any phase component. But what we want is x of e power j omega. But the problem is, you can notice that you are able to get a symmetric signal only if x of n is advanced by two samples. When you advance x of n by two samples, you just advance it by, actually we want x of n. So what you can do is, in this equation you just replace n by n minus 2 and take this right hand side to the left hand side. Okay, so you just take this as equation number 2. Okay, from 2 or into, let in equation number 2 you just put let n is equal to n minus 2. So what will happen? I am just rearranging these two because those two are equivalent mathematically. So after interchanging the left hand side and right hand side, what I will get is this one becomes x of n. X of n is equal to y of n minus 2. Okay. So here you can notice again you have x of n, and it is equivalent to y of n minus 2. So that if there is any phase component, I will be able to trace it easily. Now what you do is you just take DTFT on this. Once you take discrete time Fourier transform on this equation, x of n becomes x of e power j omega, which is equal to discrete time Fourier transform of x of n minus k. Based on time shifting property, we can say that x of n minus k is equal to e power minus j omega k into x of e power j omega. Right now we have y of n minus 2. When you apply this DTFT property, time shifting property, you will get e power minus j 2 omega into y of e power j omega. Okay, so you can notice that y of e power j omega, this is some magnitude component which is contributed due to the symmetry. This part is completely refers to the magnitude component. So you don't have to worry about what is this. The question that is asked is angle or phase component of x of e power j omega, and we have derived that x of e power j omega is some phase component e power minus j2 omega into some magnitude component. We are least about bothered about this magnitude component. Our focus is completely on the phase component. So what is angle x of e power j omega? It just refers to everything else other than j in the exponential part. So you will have finally angle x of e power j omega is nothing but everything other than j in the phase component. So you will have a minus 2 omega. This is your final phase component. Okay, so angle of x of e power j omega is minus 2 omega. So option D is correct. Okay, so we are done with the second subdivision that is given. Now let us go for the third one. The third one is we are supposed to find integration between minus pi to pi x of e power j omega into d omega. Now here we have made use of, in both the cases, our focus was completely on the DTFT formula. Now what you do is you just take the synthesis equation of DTFT. What is the synthesis equation? From synthesis equation, what do we have? From synthesis equation, we have x of n is equal to 1 by 2 pi integration between minus pi to pi x of e power j omega into e power j omega n into d omega. This is your formula. This is your inverse discrete time Fourier transform formula, also called as inverse discrete time Fourier transform. So this is what we have. Now what you can do is, in order to make this equivalent to equation number 3, this can be rewritten as 2 pi into x of n is equal to integration between minus pi to pi x of e power j omega into e power j omega n d omega. Now this part, integration between minus pi to pi x of e power j omega into d omega, is here. It remains here. It is this part. Now what you can do is, we are supposed to find only this part. So what we can do is, let us just put n is equal to 0. When we substitute n is equal to 0, we will get this particular part as such over here. So the left hand side will be your final solution. Okay, so let n is equal to 0. What happens? You get 2 pi into x of 0 is equal to integration between minus pi to pi x of e power j omega into d omega. Okay, this is what we have as such. So finally we know that x of 0 is nothing but, as a general case, We know that x of 0 is 2. This is what we have in the question. It is given as 2. This is x of 0. X of 0 is 2. So you can substitute 2 here. So altogether, this is equivalent to, I am just replacing x of 0 by 2. So I will get 2 pi into 2, which is equal to 4 pi. So 4 pi is your final solution for the third one. Okay, the idea is to make use of the synthesis equation. Just by seeing this expression form, we should be able to relate it to the inverse discrete time Fourier transform, because this part as such you have in the inverse discrete time Fourier transform. So by just rewriting it, and since we want only this particular term's equivalent numerical value, you just put n is equal to 0, everything falls in place, and you get 4 pi. So 4 pi is your final solution. Thank you.